The crisscross method, a way of writing chemical formulas. So what exactly is a chemical formula? Well, you guys have all heard of salt, and you probably know that NaCl is what makes up salt. That's a chemical formula. It's basically the symbol form of a chemical name. So sodium chloride is simplified to NaCl. The reason we do that is we could write less and to have a common code to explain different chemicals in something. So in order to do the formula, you have to make sure that the overall charge of the compound that you create has a charge of 0. So in the case of Na is a positive 1 charge, and we'll talk about how to figure it out in a second. Chloride's a negative 1. So in order to balance this, I just need one of each. So you just need NaCl. So when I write NaCl, you don't see a number next to the symbol in the bottom right here. That means it's a 1. So there's one Na and one Cl here, and that's the formula. But what if we have something like calcium chloride? Calcium's a positive 2, chloride's a negative 1. So if we're trying to write a formula for this, it's not going to be 1 calcium for every 1 chloride. The reason is that the overall charge for 1-to-1 will be a positive 1 charge. And we don't want that. Remember, we want a charge of 0 overall for the compound. That's the key to this whole method. So what do we need to do? Add another chloride. Why? Because now you have a negative 2 overall here, and you have a positive 2 over here, so they balance out. So when you write the formula, it becomes CaCl2. So that's for 1 calcium 2 chloride, the overall charge is 0. So we're going to talk about how to figure this stuff out. Now, before we do that, what we need to do first is figure out how to use the periodic table to give us some basic information. So we're going to go over that right now. So the periodic table, there's some generalities you need to know. Group 1 is always going to be a positive 1. Group 2 is always going to be a positive 2. Group 2 is going to be a positive 3. This is 1A, 2A, and 3A. There's 2 systems, remember. There's the A system, 1 through 8, and then there's the just numeric system, which takes you 1 through 18. We're going to use the A and B system. So for our purposes right now, group 1 is positive 1, group 2 is always a positive 2, group 3 is positive 3. So any member of these groups have that charge. Likewise, nitrogen is going to be a negative 3. That's every member of this group. Oxygen is going to be a negative 2, and fluoride is going to be a negative 1. Carbon's a little weird, so we're going to ignore those for now. Those charges you have to know. In order to be able to do basic formula writing, you have to use a periodic table to get this basic information. So you do need to memorize those charges based on the groups. You also need to know that there are 3 elements that also have a constant charge. Now, the majority of these have variable charges. What that means is that they have more than one possible charge, like iron is a positive 2 or a positive 3. So what you want to do is, for those, you would need to use some a little bit more thinking and not necessarily memorizing more stuff, but you would have to approach it a little differently. So we're going to go over the 3 that don't have that, even though they're in this middle section, which is where the variability comes in. Zinc, ZaC basically, has constant charges. So zinc is always going to be a positive 2, Ag is going to be a positive 1, Cd is a positive 2. So if they tell you cadmium chloride, you know right off the bat cadmium is a positive 2. So you need to memorize that. Same with zinc oxide, zinc is a positive 2. These charges are not variable. They only have one possible charge. Just like these elements here we just showed you a second ago, those are constant charges, so do these. So you do have to memorize that. Now, once you know that, let's get back into actually using that information. So strontium is a member of group 2A, so it means positive 2 charge. Fluoride is a member of group 7A, so it's negative 1. So what is the crisscross? Well, you saw how I did that here, right? I just basically looked at the ratios and tried to get the 0. That gets kind of time consuming. So there's a faster way. The faster way, you take the number here, you put it here as a subscript, take the number here, you put there as a subscript. That's what the crisscross means. So this becomes SR1, right? Because I'm bringing the 1 over here. I'm not going to write it because you never do. At least for 1, you don't. And then F2. Why? Because this 2 goes over here. You notice I didn't bring the charge with it. I just brought the numbers. That's all crisscross is. Just take the number, ignore the charge, and crisscross it to the other side. So now this is a neutral compound. You can verify real quick, right? SR is a positive 2. There's 2 F's based on a formula. Positive 2, negative 2. Net charge is 0. We're good. That's the objective, right? You have to get the 0 for these compounds. Otherwise, you have screwed up. So this rule for 1A, 2A, and 3A, where the charge is represented by the group number, that's what all these are. So all these are going to abide by that rule. So calcium is a group 2A element, so 2 plus, oxygen is a negative 2, looks like that. So when we crisscross it, we actually get this, right? We get Ca2O2. So there's two different ways you can approach this. One, whenever the charges are identical, it's just going to be a 1-to-1 ratio. Just going to be CaO. That's just always that's going to be, because if you did it the other way, right? Like right now, would you need to add any more of either one of these to make the charge 0? No, it's already 0, right? So because of this situation, you could either just, whenever the charges are identical but opposite, just put 1-to-1 and call it a day. Or the most important rule for writing these crisscross method formulas is that you have to reduce the lowest common multiple. So the lowest common multiple for 2 is 1. So you would actually sit there, reduce this down to 1 and 1. So either way would work, but remember this whole reduction thing is going to come back a little later. All right, lithium oxide, group 1A for lithium, it's positive 1 charge. Oxide's negative 2 because it's group 6A, Criss, cross. So Li2O. We're done. Aluminum phosphide. Aluminum's a positive 3. Phosphide's a negative 3. So two choices, right? We could do this whole same charge as opposite, so it's going to be ALP. Or we could sit there and actually do the 3 and 3 and reduce it down. I think it's just easier when you see the same charges, just 1-to-1 and call it a day. So that's if you have group 1A, 2A, and 3A. So that's just how you approach it. Okay, what about type 2? 2 elements only with metals whose charge is represented by a Roman numeral. So these are metals except for Z and CD and Ag, which are not in group 1A, 2A, and 3A, that have multiple charges. So if it's any of these three, or members 1, 2, and 3A, you know the charge. There's nothing cute you have to do. You just sit there, crisscross the charge based on the periodic when you're done. For these other ones, they're going to have to tell you the charge. And then the way they can tell you the charge is Roman numerals. So I represents positive 1. 2 is represented by, 2 I's represented by positive 2. 3 I's represented by positive 3. This is IV, positive 4. V is a positive 5, and VI is 6. That's as high as we're going to go. That's as far as Roman numerals we're going to go. So because of this, you just have to memorize the Roman numerals and what number they correspond to. Now, they always represent the metal. Please do not think that these charges can ever be used for the non-metal. And in case you didn't notice, this is always going to be the cation. This is always the anion. Remember? Cations are the ones that lose electrons. That's why they're positive 2. Anions gain electrons. That's why it's negative charge. So a cation and anion get together now in a compound. That's what an ionic compound is. Two oppositely charged ions getting together to form a compound. They're merging. So with that in mind, make sure you understand that you always put the cation first, then the anion. That's always the case. The anion, usually you see an IDE ending for most of these, and we'll come back to that a little later. But all these are going to be I'd, right? There's a different class called polyatomic ions we'll be dealing with a little later, where you're not going to see IDE, you're going to see AT and IT, but we'll talk about those in a minute. For now, for this stuff, for the Roman numeral stuff anyways, so they give you the charge. So same thing we did up here, except we don't look at the periodic table for these. At least we don't need to for cobalt. So cobalt is VI, so that's 6. So positive 6 charge. Nitride, negative 3 charge. So crisscross, right? Crisscross, CO3, N6. Now remember, at the end of writing this, you got to make sure you can't reduce it. If you can, you reduce it. So this can be reduced. So both of these are multiples of 3. So 3 goes into 6 twice, 3 goes into 3 once. Your actual formula becomes CON2. So what happens if you don't write it this way? You'd be marked wrong. You can't write it this way. Whenever it can be reduced, you must reduce it. That's the only catch with the crisscross method. Otherwise, you're going to have to do this kind of thing for all the questions, which is even more of a headache. Okay, lead 4 fluoride. Lead, positive 4. That's what Roman tells us. Fluoride, negative 1. Criss, cross, PBI, 4. It's extremely important you write this part out. I mean, a lot of students will try to shortcut the students in your head. Don't. Just write it out, do the crisscross, make it simple for yourself. Many a student has messed up because they sat there and tried to do the whole crisscross thing in their head, and it's just a disaster. So don't do that. All right, next one. Cobalt 6 oxide, CO, cobalt 3, excuse me, positive 3, oxide, negative 2, Criss, cross, CO, 2, O, 3. And you're done. It's already reduced. You're good to go. Cobalt 4, nitride, cobalt, positive 4. It's IV, right? Nitride, negative 3. Crisscross, CO, 3, and 4. Can't reduce this, can't reduce this. So you're done. That's all you got to do. So with the one with Roman numerals, you use the Roman numerals to figure out the charts. You do need to know what the Roman numerals represent. All right, the third class are the ones that involve polyatomic ions. Now, polyatomic ions are those ions that are compounds, but they have charges. So most compounds, especially all these ones you've seen, charge is 0. Polyatomic ions are things like phosphate, which is a PO4, negative 3 charge. Now, usually when you see a compound, which is 2 or more elements together, you expect no charge. But polyatomic ions have charges. You do have to memorize all the different polyatomic ions to make your life easier. The way you recognize them compared to a regular anion, so like phosphate can be easily confused with phosphide. What's the difference? This is actually a P negative 3, whereas this is PO4 negative 3. So how can you tell them apart? The IDE. When it's IDE, it's going to be just a single element, not a polyatomic ion. When it's ATE or ITE, it's going to be a polyatomic ion. So that's one way to recognize it. The only exception, and I do want to make this clear, is hydroxide. Hydroxide has an IDE ending, but it's actually OH negative 1. That is the only polyatomic ion that has that weird quirk. Everything else can either end in IT or AT, so be aware of that. So anyways, for these, same approach as far as crisscrossing, except you have to pay attention to a couple of little rules. So for chromium 6, that's Cr, positive 6, phosphate PO4, negative 3. So here's the thing. When you crisscross this, most students will look and say, well, does that mean I do 6 times 4, which is 24? No, you don't. Do you add them together, make it 10? No, you don't do that either. So what do? Whenever there has to be a number on the outside of the polyatomic ion, you're going to put parentheses around the whole thing. So watch. I'm going to crisscross again. I'm going to make Cr3. That's easy. But for PO4, because I need a number on the outside, I'm going to put parentheses around the whole thing. Why? Because we're saying collectively is I have this many phosphates. So in this situation, you have 6 phosphates. So for polyatomic ions, whenever there's a number on the outside, you have to put parentheses. If this was, let's say, aluminum phosphate, aluminum is a positive 3, phosphate's a negative 3. When you crisscross, remember if it's the same charge as 1-to-1, you don't have to put parentheses around it. And the reason you have to put parentheses is because the fact that this does not have a number. You have multiple of them. You just have a single one. You just have one PO4. So be aware of that. Don't get parentheses happy and put it on everything. That's the most common thing I see. In any case, we still need to reduce this, right? Because this is 6 and a 3. So 3 goes into 3 once, goes into this twice. So I end up with Cr, PO4, 2. There's my final answer. All right, molybdenum, MO. This is a 6, positive 6. Phosphite, that's PO3, negative 3. This is why it's important to memorize polyatomic ions. Because trying to distinguish between phosphate and phosphite, without memorizing it's going to be impossible. So same thing, Criss, cross, MO, 3, PO3, parentheses, right, because we have a number on the outside, reduce 1 twice, so we'd end up with MO, PO3, 2. Pretty hard question. Copper 2 phosphite, we're going to do Cu, positive 2, because Roman numeral, right? Phosphite, PO3, negative 3. Criss, cross, Cu3, right? 3 goes down there. PO3 with a 2 on the outside. So for that particular one, no reduction is necessary. And by the way, you don't ever reduce these numbers. They're part of the formula. Like the 3, you don't reduce it. Like if this was PO3 and CU3, don't do 3 and 3 cancels out, make 1 and 1. You can't do that because now you have PO. What the heck is PO? So you can't touch the bottom number on these polyatomic ions. That's very important to note. You could touch number on the outside of the parentheses, but you can't do the number inside. All right, cobalt 6, so CO, positive 6, sulfate, SO4, negative 2, crisscross, CO, 2, SO4, 6, reduce, 2 and 2 goes once, 2 goes 6 goes 3 times, so you end up with CO, SO4, 3. The next one, ammonium phosphate, ammonium's NH4, positive 1, phosphate PO4, negative 3, crisscross NH4, put a 3 on the outside, PO4, we're done. And the last one, iron, positive 2, SO3, negative 2, 1-to-1 ratio, right? Negative 2 plus 2, you don't touch anything at the bottom number, Fe, SO3. So that's how you do the crisscross method using different types of substances.